Now we have Cambridge IGCSE chemistry. So this is the course for IGCSE, and also it is for GCSE. It is almost the same. So, okay, chemistry. So this is the table of content, state of matter, atomic, atoms, elements and compounds, bonding and structure, stoichiometry, chemical calculation, electrochemistry, and chemical energetics. Chemical reactions, acids, bases, and salts, periodic table, metals, chemistry and the environment, organic chemistry 1, organic chemistry 2, experimental techniques. So this is the table of contents for IGCSE and GCSE chemistry. Okay, now atoms, elements and compounds. So we can start read through this one. Neutrons and protons have a similar mass, whereas electrons possess very little mass. So the mass of any atom depends on the number of protons and neutrons in its nucleus. The total number of protons and neutrons found in the nucleus of an atom is called the mass number or nucleon number, and is given in the symbol A. So we stated this part last week. Now we will go through some examples to highlight this concept. So key definitions. Okay, the first definition is a proton number. So proton number or atomic number is the number of protons in the nucleus of an atom. The second definition is mass number or nucleon number is the total number of protons and neutrons in the nucleus of an atom. So now we will have this definition, which is very important in our session. Now, mass number equals to proton number plus the number of neutrons. So mass number is equal to proton number and number of neutrons. Okay, now you see we have this example, the helium atom. So the helium atom in figure 214, we went through this figure last session, has a mass number of 4 since it has 2 protons and 2 neutrons. So the helium has 2 protons and 2 neutrons in its nucleus. If we consider the metallic element lithium, you see, in helium we have its mass number is equal to 4 and since it has 2 protons and 2 neutrons. So now if we consider the metallic element lithium, it has 3 protons and 4 neutrons in its nucleus. It therefore has a mass of 7 because it is 3 here and 4 here. So the mass number is 7. The proton number and mass number of an element are usually written in the following shorthand way. So we can have a look on this one. This is the symbol of element He. A is the mass number. So we have 2 numbers. The upper one is the mass number. The lower one is the proton number. And this one, the symbol is A for the mass number, and for proton is Z. So, and this one is the symbol of element. Usually these are listed, you see, these are listed, this is for helium, but for other elements all are listed in a table like this one. So if we come to hydrogen, its symbol is H, proton number is 1, number of electrons 1, number of protons 1, number of neutrons it is 0, so the mass number is 1. Okay? Carbon, the symbol is C, proton number 6, number of electrons, and so on. So now we will go through one example to solve. This is worked example. Example number 1, what is the number of neutrons in one atom of Mg, which is the magnesium? Mg, you see, Mg is 2412. If you come here, you see, this is the 24 mass number, this is the mass number, and the 12 is the proton number. You see, proton number, or proton number, you see, proton number. So I can read through magnesium, it is 12 the proton number and mass number of 24. So what is the number of neutrons in one atom of Mg? 24 over 12. We will use this one. Number of neutrons equals mass number minus proton number. It is from here, you see. Number of neutrons, you see, if I want, because A equals Z plus number of neutrons. If I want number of neutrons, so it will be mass number minus proton number. And in that case, it is 24 minus 12. This is from table. These two values are from table, or it is given in a question, and this one is the required result.